Hey everyone, how are you? In this video, we are going to solve the Leetcode problem of the day, and the problem is longest subarray with maximum bitwise AND. Now, the problem category is of medium level, but I would say if you know about bitwise AND, if you know the properties of bitwise AND, this is going to be very easy for you because the problem is actually very easy. You just need to know about a property of bitwise AND. I will tell you that. The input given in the question is integer array, and let us call it as nums. We need to give the output as the length of the longest subarray. So basically, we need to find a subarray whose length is longest, and that subarray whose bitwise AND is equal to the maximum bitwise AND of any subarray. So the thing is, you need to find a subarray which is possibly the longest, right? And you need to make sure that the bitwise AND of your longest subarray should be equal to the maximum bitwise AND which is possible for any subarray of your given input array nums. So first of all, we need to find the any subarray. We need to find a subarray who has the maximum bitwise and then only we can find another subarray which is longest but has the bitwise AND equal to the maximum bitwise AND, right? Now let's try to understand this with input. Let us say the given input is 1 2 3 3 2 2. Now the thing is, before you proceed solving the problem, let us try to understand about bitwise AND. Since few days we were mostly working on bitwise OR, right? Last few days problem of the day were on bitwise OR, and bitwise OR is a progressive operation, I would say. When we say it is a progressive operation, it means that you take the bitwise OR of, let us say, four numbers A, B, E, and the output is X. Now if you take the bitwise OR of X with any other number, let us say you take the bitwise OR of X with Y, then the output will never be less than X. The output is always going to increase. Either it will be more than X or it will be equal to X. This was the property of bitwise OR. But talking about bitwise AND, the property is just opposite. It is a non-progressive operation. It means if you take the bitwise AND of, let us say, four numbers A, B, C, D, if this is equal to, let us say, X. Now if you take the bitwise AND of X with Y, the output will always be less than X or equal to X. The output can be less than X or equal to X. It means that bitwise AND is a non-progressive operation. Its value is going to decrease or will be equal. Now in what case the value will be equal? Let me show you that. Let us say the two numbers are 3 and 3. You take the bitwise AND of 3 and 3, it will be equal to 3, and the reason being the bitwise of 3 is 1 1, the bitwise of 3 is 1 1. I mean, if you convert the 3's in bits or binaries. Now if you take the AND, this 1 1 will be 1, this 1 1 will be 1, which is actually equal to 3, right? So when the numbers are same, the output is going to be same. Now with the output, if you take the AND with 3 again, this will again be equal to 3. But if you take the AND of 3 with, let us say you take the AND with 2, now this will be equal to 2 and not 3. This is going to decrease. Or let us say you take the bitwise AND of 3 and 20, still it is going to decrease. It will not be equal to 3. It is going to decrease, because if we convert 3 to binary, it will be 1 1. You convert 20 to binary, I think it will be 1 0 1 0 0, right? Now if you take the bitwise AND, this 1 with 0 will be 0, this 1 will with 0 will be 0, then 1 with other zeros will be 0 0 0. So this will actually be equal to 0 if you take the bitwise AND of 3 and 20. So from here you will notice that the bitwise AND is a non-progressive operation. It is always going to decrease. Now if I ask you, can you find a sub-array for which we have the maximum bitwise AND in given array? So it will always be equal to the maximum element we have in our array. Because if this is my maximum element, let us say 3 is my maximum element. If 3 is the maximum element, then you can say this is my sub-array just of one element. This is a subarray with one element, right? It is a valid subarray. If your subarray is just having one element, then the bitwise AND will be equal to 3, right? It will be equal to the number itself. Now you should not take another number in your subarray for which you want to find out the maximum bitwise AND, because let us say your current array is having just one number which is the maximum of your input. But if you want to take another data, I mean, if your subarray is having one element which is 3, if you want to take another data in your subarray, and let us say the data is X, see, the thing is, the output of this will never be more than 3, right? It is always going to decrease or will be equal. So there is no use of taking another element in that subarray which has the maximum bitwise AND. As of now, we are not trying to find out the longest subarray. We are trying to find out the subarray who has the maximum bitwise AND. And that will always be equal to a subarray with one element. That one element should be the maximum, right? Now, once you know that what is the maximum bitwise AND of any subarray, now you can try to search for a subarray which is the longest but still having the bitwise AND equal to the maximum. So from here what we can understand is, first of all, try to find out what is the max value of your array. The max is 3. Now try to find out a subarray whose bitwise AND will be equal to 3, but you want to find out a subarray whose length is maximum. Now again coming back to a very important property of bitwise AND, which is it is non-progressive. From this property what we can understand is, if I take this 2, if I take this 3, if I take the AND of 2 and 3, right, then the output will never be more than 2. The output can never be more than 2. Think about this. If you have the number 2, right, if you take the number 2, take the AND of this number 2 with 3, right, 3 is my next number, right. As of now we are trying to build the longest subarray, and let us say we select this number 2 and then we select the number 3. The output of this operation can never be more than 2, and the reason is, let us say your first number is 2, this is your current AND value, right. You take the AND of this particular value, the bitwise AND of this particular value with any other number. From the bitwise AND property it says that the output can never be more than this, more than 2, right. The output will never be more than the lower number. So from here what we can understand is, I cannot include any number which is less than my maximum number, because if I include any number less than my maximum number, the bitwise AND of that subarray will not be equal to the maximum. So from here the question is converted into a different question. Try to find out that subarray who is having the longest continuity of max value. That is, try to find out the longest continuous subarray in which the elements are 3 or the elements are maximum. For this particular given input, this is the output 3 comma 3, and the reason is all the elements are 3. If I take 3 and 3 and 3, and if I keep taking and, that is bitwise AND of 3, this will always be equal to 3. It means I just need to find out the longest continuous subarray in which the elements are equal to my max value. So from here what I can say is, let me scan every element. Is this equal to 3? No. And before scanning we should find out what is the maximum. Once we know the maximum, what we can do is we can say, is this the maximum? No. Is this the maximum? No. Is this the maximum? Yes. The moment we get a yes, we can say that at least we found a subarray whose length is 1. Is this a maximum? Yes. So now this is a continuous subarray whose elements are equal to 3. My previous count was 1, now this will be 2. Now is this the maximum? No, it is not the maximum. So our continuous subarray got broken, right? But the last answer we got was 2. That is, we found a subarray whose length is 2. So that is my current result. That can be my current result, right? We still need to scan the other 2 elements. So is this the maximum? No. So my current count will be 0. I have already stored a result which is equal to 2, but this is not equal to maximum. So the current count is 0. Current subarray length is 0. Is this the maximum? No. So the current subarray is having a length of 0. Now let us say the input is having another 3 elements, 3 comma 3 comma 3. So we will scan more, right? Now this is equal to maximum, right? So we again started to create a subarray whose elements are 3. As of now the length is 1. Then we scan the next element, the length is 2. Then we scan the next element, the length is 3. Now the moment it is 3, we are going to update our previous answer. That is because previously we got a subarray of length 2. Now we got a subarray of length more than 2. So our answer will be not 2 but 3. As of now it is 3. And let us say there are more 3's, then the answer will keep on increasing, right? Now that's the complete logic. We don't have to overcomplicate the things, because that is the actual complete logic to solve this particular problem. Now let me get back to the code editor and let me try to show you the solution in Python. So first of all, we are trying to find out the maximum value of our given array nums. Then we create 2 variables, result is equal to 0 and count is equal to 0. Result will store the final count, and this count will store the count of the current subarray or the count of the length of the current subarray. Now we just run a simple loop in our array for right in the range of length of nums, and if my current element, that is nums of right, is equal to maximum, we are going to increase the count. Else we are going to update our result and we are going to say my current result will be the maximum of count and result, and then we are going to reset the value of count. We are going to come in this else condition when the current element is not equal to mx, that is our continuous subarray whose elements has to be the maximum got broken. Now we got another element which is actually less than the maximum, right? And finally we can return the maximum of count and result, that is whatever was the last count I have counted and whatever was the last result we have, whatever value is maximum, we are going to return this, because that is going to be the longest subarray whose bitwise AND will be the maximum. Now you can submit this and this is going to pass all the test cases, and this is a very efficient solution for this particular problem. You can see the runtime is very good, the memory used is very good. So we have solved this problem in a very efficient manner. So that's it for this video, guys. If this video helps you to understand the problem and the solution, and more than the solution, if this video helps you to understand the intuition behind the solution, then make sure that you hit that like button. And if you are not subscribed to my channel as of now, then make sure that you subscribe to the channel as well. And I will see you guys in the next video. I want to see you guys in the next video. Thank you for watching this one.